in today's lecture, we are going to see what is modulation and what is the need for modulation. So before going to what is modulation and the need for modulation, let us see what is a communication system. So a communication system is the one which is used to exchange the information between the source and destination. So a communication system consists of is information source, a transmitter, channel, and a receiver, and finally the destination. So whatever the information we want to send, that is given to the transmitter, and once the signal is modified at transmitter, that is sent through a channel to the receiver. At receiver, again, this information from receiver, it retrieves back the original information and give it to the destination. So the main purpose of transmitter is to modify the signal, message signal, into a suitable form for transmission over a channel. So what is that modification of the signal? So the modification of the signal is nothing but your modulation. So let us see what is a modulation. So the strength of the message signal should be increased to that it can travel longer distance. So this is where the modulation is essential. So the most vital need of modulation is to enhance the strength of the signal without affecting the parameters of the carrier signal. So, by definition, modulation is defined as the process by which some characteristics of carrier is varied in accordance with the modulating signal, that is the message signal, is called as modulation. So, what exactly the modulation is doing here is we are going to shift the frequency of a low frequency signal to a high frequency signal which is suitable for transmission. So what is the need for modulation? So when I look into the need for modulation, so message or the information and signals are sent from one part of the world to another part within minutes. So this is achieved by the process called as modulation. So the modulation process plays a major role in the fast transmission of your signal. So why? So uh, with modulation, only fast transmission is uh, not only the advantage. We have so many advantages which are here. One is the reduction in the height of the antenna. Second one is avoiding mixing of the signals, increasing the range of communication, allows multiplexing of signals, allows adjustment of bandwidth, and improves the quality of reception. Let us see what is each and every advantage of modulation. So first we'll see reduction of height of the antenna. So when the transmission occurs over a free space, the antenna radiates the signals and receiver receives it. To operate it efficiently, antenna need to be in the order of the magnitude of wavelength of the transmitted signal. So which is given as lambda, or length of the antenna is nothing but which is given as the magnitude of your wavelength, which is given as u by v, where u is the velocity of the light in the free space and v, you can see that is the frequency what we are using. So let us discuss this one in detail with an example. Now, all we know that the audio frequency ranges from 20 hertz to your 20 kilohertz. Suppose that this is a frequency of 20 kilohertz audio frequency, or and it is radiated to a receiver through a channel in the free space. Then the length of the antenna which is required is 3 into 10 to the power of 8 by 20 kilohertz. So that means it requires an antenna height of 15 kilometers, which is impossible to build an antenna of this much big size. So what is we are doing is, so instead say let us we give a chance for the modulation. So the frequency whatever the 20 kilohertz we are uh, using modulation, we are increasing using a 1000 kilohertz carrier wave to carry the signal. Then the length of the antenna now required is 300 meters. Now, this is much more possible, and this example clearly shows that how immensely the modulation process enables the communication system. Second parameter, that is avoiding mixing of the signals. So all the sound signals are within the range of 20 to 20 kilohertz, and the transmission of your message signal from various sources cause mixing of the signals, and it is difficult to separate at the receiver end. So in order to separate the various signals, it is necessary to translate them into different portions of your electromagnetic spectrum. So each has to be given its own bandwidth known as channel bandwidth. Now let us see. So this can be achieved by modulation by taking different carrier frequencies for different signal sources. You can see here in the figure, like we are considering three signals which are having the same frequency, that is 20 kilohertz. Now with the modulation, what we are doing here is the signal 1 is getting modulated with a carrier of 100 kilohertz. Signal 2 is modulated at a 200 kilohertz. Signal 3 is modulated at 300 kilohertz. So when we do the modulation, so because of these three different frequency carrier frequencies, it avoids mixing of the signals when they are transmitted. Now, third one is like increasing the range of communication. So at low frequency, the radiation is poor and the signal gets highly attenuated. That means it cannot be traveling for the longer distance. So we cannot transmit the message signal directly over a long distance. The best example is our voice. So whenever we speak, it can reach up to uh, a small distance. So if modulation is done, the modulation effectively increases the frequency of the signal to be radiated and thus increases the distance over which the signal can be transmitted faithfully. Next comes your allows multiplexing of the signal. Modulation allows multiplexing of the signals. So multiplexing means transmission of two or more signals simultaneously over the same channel. So here we have two types of multiplexing of signals. One is frequency division multiplexing and the other is time division multiplexing. So let us see what frequency division multiplexing is and what a time division multiplexing is. So frequency division multiplexing. So using a carrier to shift the frequency band of the message signal for simultaneous transmission is known as frequency division multiplexing. That means we are using a different frequency bands for transmission simultaneously. The best examples what we have is radio broadcasting, satellite communication, and cell phones. So the other one, that is time division multiplexing. Here the multiplexing can be achieved by dividing the time between two samples of the signals in various time slots and using each time slot to send one digital signal is known as your time division multiplexing. So here the best example is your television channels. So in the frequency division multiplexing, we use the same time slot, whereas in your time division multiplexing, we use a different time slots. So how this modulation is used to allow the adjustment of bandwidth. So bandwidth of the modulated signal may be made smaller or larger than the original signal. So signal to noise ratio in the receiver, which is a function of the signal bandwidth, thus can be improved by proper control of bandwidth at the modulating stage. That means at transmitter side, when we are doing modulation, so that can be controlled. So finally, improving the quality of reception. Using some modulation techniques, the effect of the noise can be reduced, which improves the quality of reception. So finally, when we do modulation, we have so many advantages, and finally, we can send the information for the longer distance, and the quality of reception of the signal is also improved with using a proper modulation techniques. Thank you.